6 segment lengths in circles. So we're going to have secants, tangents, and we're really going to be talking about the lengths of the segments they make inside the circle. So the first one, we're going to talk about Theorem 1014, segments of chords theorem. Segments of chords theorem. Okay, so here is a picture, and I'm going to read through what this says, and then we're going to do a problem. This is A, this is B, and I'm going to do this a little bit extreme here. So there's the picture. Here's the theorem. If two chords intersect in the interior of a circle, then the product, what's the product mean? What's the product mean? Multiplication. Then the multiplication of the lengths of the segments of one chord is equal to the product of the lengths of the other chord. Okay, so what we're saying here is AE times EB is equal to, of course that's that first chord there, is equal to DE times EC. So each individual segment in there that makes up a chord, you multiply that together, it equals the length, the product of the other segments. Okay, so let's do a problem. I'm going to do, look at number 5. Put that up there so you can see it. Number 5 looks, actually not number 5. All right. That will work good since I got it on. Number 5. This is 6, this is 8. That is x right there. And this is x plus 8. Okay, so I'll work this out up here so we can see it. So what this is saying is, this little segment here and this segment, we multiply them together. So x times x plus 8, that's the length, or the product of the chord, is equal to this, 6 times 8. So now what? Solve. Distribute. X squared plus 8x equals 48. So all you wonderful, awesome algebra students, how do I solve this problem?
You subtract 48.
Subtract 48 to the left, so I get x squared plus 8x minus 48 equals 0. Then what? Factor and use the zero product rule. So what does it factor into? Everybody in here, you're honor students. You're going to get eaten alive if you don't know your factoring. This is a 1. This is the easiest factoring there is. Factors of 48 to add up to 8. I'll wait.
12 and 4.
What are the signs?
Positive 12 and negative 4.
Positive 12, negative 4. Zero product rule says this. If this is 0, the whole thing is 0. If x minus 4 is 0, the whole thing is 0. So x is either negative 12, that's what makes this go to 0, or x is positive 4. Well, x can't be negative. We're talking about length. So the answer is 4. Who had me for algebra 1? Raise your hand. Would you like to do chapter 9?
Yeah.
Would you like to do it again? Then I better see some awesome factoring. And the rest of you better step up. Factoring is the most important concept in all of high school. Moving on. I'm sure your parents would not be happy if I gave you 80 problems tonight, just for factoring. Next theorem. Theorem 1015. This is called segments of secants theorem. So before we just had chords, here we're going to have secants. Segments of secants theorem. So here is the picture. E, C, D. Okay, so segments of secants. What you do is you take the whole secant, EB, times the outside segment, not the inside, EA. Set that equal to the whole secant, ED, times the outside segment, EC. Got it? The whole segment times the outside segment, the whole secant times the outside segment is equal to the whole secant times the outside segment. Okay, let's see if you got it. Let's do an example. Colorful. Let's do number 7. Here it is. There's the picture. This is 5. That's 7. This is X and this is 4. The whole secant.
7's the whole thing.
Nope.
Is that okay?
So the whole secant here is what?
12.
Well, what's the whole secant here?
X 4.
X plus 4. So you're going to have 5, or the whole secant, 12 times 5, equal to the whole secant, X plus 4, times the outside segment. Everybody calculate that and figure it out. So 12 times 5 is 60. Distribute the x, x squared plus 4x. Get the 60 over there on one side. Factor 10, negative 6. X cannot be negative, so the answer is positive 6. Who got that right? Yeah, let's move on. Last theorem. And it is just like this. So I'm not actually going to tell you the last theorem. We're going to apply the theorem you just did to show you what the answer is, how you do this. This is 1016 segments of secants and tangents theorem. Okay, so here's the picture. You've got a tangent at A and a secant, C and D. So let's talk through this. Let's just say this is what we had, and you're going to use the same theorem you just did. First of all, let's do this one. So the whole secant, ED, times the outside segment, EC, is equal to the whole secant, EA, times the outside segment. Well, what's the outside segment? EA. So that's ED times EC equals EA squared, which is what the theorem is stating. So it says the same thing. You just, if you want to memorize the formula, that's fine, or just remember that's how you come up with it. So let's do a problem. Is that all right? Everybody ready to do a problem? circle, got a secant, this is 12, this is x, and here's the tangent, x plus 4. Go ahead and try to work that out. Let's see if you get the right answer. What's this over here? Well, the whole secant is 12, or x plus 12.
Oh, yes.
X squared, but you gotta do it like this. This is right. The whole secant is x plus 12 times x. Oh. Got this? You guys got this? Kind of doing it all in your head, huh? Okay, let's at least set it up correctly. Now use a marker, that's better. So the whole secant here is x plus 12. So x plus 12, you got to take that times the outside segment of x. That's equal to the x plus 4 squared. So let's distribute. We get x squared plus 12x on the left. And then this is x plus 4 times x plus 4. If you don't know the special case formula, then you have to divide it out like this and distribute. Okay, so x squared plus 12x equals x squared plus 8x plus 16. And don't put the 2 on both of those. You need to make sure you understand there's a middle term there. Okay, now the x squareds cancel. Bring the 8x to the left, I get 4x equals 16. X equals 4. We got that right. Alright. I know some of you were doing it wrong, so hopefully that helps. But that's really what you're doing. Any questions? Alright, so we got 3 different types of things again today. Tomorrow is a quiz. Today's assignment. Today's assignment is page 692. 3 to 18 all. 21,